Today we're going to finish up section 6.3, logarithms and logarithmic functions. So we're going to talk about inverse today. And if you recall, inverses are when we were taking the two functions and we switched their x and y values and solved for y. We also recall that inverses were graphs of each other reflected along the line y equals x, and also the input of one was the output of the other, and vice versa. So we do have inverses for logs. So by the definition, if I have the function g of x equals log base b of x, the inverse of that function would be b to the x. So basically, they take the part that's right here, and that becomes the inverse, b raised to the x. And vice versa. If I started with b to the x, I can rewrite it as the inverse as log base b to the x. And if you recall, we also could tell if things were inverses by taking the composition, where we did g of f of x, and it equaled x, and we did f of g of x, and that also equaled x. So what they're really doing here is they're saving us some of the work, right? We know automatically that these forms are inverses of each other, and we know both of these are true because they are inverses of each other. This allows us to simplify some, knowing the fact that log base b of b to the x is really x. So basically the log base b cancels and we just get x. And also b to the log base b of x is x. So basically the b and the log base b cancel again. So if I want to simplify these, all right, this, remember, if it doesn't have a number there, it means a base of 10. So this could really be rewritten as 10 to the log base 10 of 18. So these two parts will cancel. The 10 and the log base 10 will cancel, and my answer is 18. And that's all I have to do for that. All right? As long as the base of the log and the number here match, we can cancel them out. So I have log base 4 of 16 to the x. So I need these two things to be the same to cancel them. So I need to find a way to rewrite 16 as a 4. So I'm going to start with my log base 4. And I know 16 is really 4 squared. So it's 4 squared to the x. So this is really log base 4 to the 4 to the 2x. So the log base 4 and 4 cancel, and my answer is 2x. All right, you guys go ahead and try the next two. Pause when you're ready, come back and check your answers. All right, so for the first one, the log and the log base 8 canceled, so my answer is x. In the second one, this 64 can really be written as 2 to the 6th. So this was log base 2, to the 2 to the 6x. So these canceled, and my answer was 6x. All right, now we're going to focus on finding the inverse. So if it's written in the form y equals b to the x, if you recall from the very beginning, we said y equals b to the x is the inverse of log base b to the x. So I don't really have to even do any work. I know if it's y equals 11 to the x, my inverse is going to be y equals log base 11 of x. And that's all I have to do. All right, I'm going to write it up here again. That inverse is y equals b to the x and y equals log base b of x are inverses. So as long as I have it written in one of those forms, I can automatically put it into the other one. For b, it's a little different. We don't have the actual inverse written of a natural log. But if you recall, the natural log's base is e. So what I can do to get rid of the natural log is I'm going to raise it to the e power, right? Anytime we had something and then something raised of that log, they canceled. I'm going to go back here just to talk about that again. I had something and then the log with that same base, those canceled out to just give us that value. So that's what we're going to do here. I know that if I do e to the natural log of x plus 6, these two things get to cancel each other out. But if you recall, what you do to one side of an equation, you have to do to the other. So I'm also going to be putting y as that. And you know what? I'm going to stop you right there, stop myself right there, because I forgot the most important step of finding an inverse. I said it before when we talked about inverses. You switch the y and the x, and then you start to solve. So I'm going to get rid of this. I'm going to try again. Look at that. Even Miss Nellis makes mistakes. I'm going to blame the fact that I'm all allergied up today. All right, so we're going to switch x and y first. So x equals natural log y plus 6. Now I'm going to raise both sides with e as my base. Okay, so e to the x equals e to the natural log of y plus 6. On this side, those two parts get to cancel. So I get e to the x equals y plus 6. And I just have to solve for y. So I could do that by getting rid of the 6. So now I have e to the x minus 6 equals y. And that is my inverse. All right, I apologize for that. So I want you to try the next two. For the first one, it's going to be just like the first example here. It's already in the correct form. Use the fact that we know this to find it. The second one is going to be like the b we just did. It's a natural log, so you're going to have to raise it with e as a base. Pause when you're ready, come back and check your answers. All right, those should be your answers for these problems. All right, the last part of section 6.3 is about graphing logarithmic functions. So they're kind of a backwards way to graph them. All right, so again, we know that the graph of inverses reflect over the line y equals x. So if I know the graph of b to the x, I know the graph of log base b to the x. So that's what we're going to do. If I want to graph a log function, I'm really going to focus on graphing its inverse. And then I remember that inverse switches input and output, and that's really what I'm going to do. So here are our steps. So for graphing a logarithmic function, I'm first going to find the inverse. All right. Then I'm going to make a table of values for that function. Then I'm going to flip the x and y values in that table, and I'll graph those coordinates, because that's now back to the original function. So we're kind of doing double the work to make it easier, really, on ourselves. So for this one, I want to graph f of x equals log base 7x. So that means the inverse is y equals 7 to the x power. Sorry about that. So whenever I make a table of values, I usually tend to try like -2, -1, 0, 1, 2. And I'm going to plug each of these into this. So 7 to the -2 is like 1 over 7 squared. All right, that's what happens with negatives. So this is 1 over 49. -1, so 7 to the -1 is the same as 1 over 7 to the first, which is 1/7. 7 to the 0 power, anything to the 0 power is 1. 7 to the first power is 7, and then 7 squared is 49. So what I'm going to do now is I'm going to take each of these x values, and I'm going to put them as f of x for my new chart. right? We're flipping our input and our output. So everything that was the output in the inverse is now the original value in the logarithmic function. We obviously can't graph all of them, but we'll graph what we can. So 1/49th comma negative 2 is almost 0 comma negative 2. 1/7 comma negative 1 is barely anything bigger comma negative 1. Then I have 1, 0. I have 7, 1. And I'm not going to be able to graph 49 comma 2. So I'm going to do my best, right? We're going to go like this, connect our dots like that. Make sure we stick arrows at both ends. And that would be the graph of log base 7x. All right? I'm not asking you to graph the inverse. You could if you wanted to, and then we could even graph the line y equals x to show that it is the reflection, but we don't have to. All right, let's do another one together before you try. So now I have f of x equals log base 1/2 x. So that means my inverse is 1/2 to the x power. I'm still going to do negative 2, negative 1, 0, 1, 2. So 1/2 to the negative 2 power is the same as saying 1 to the negative 2 over 2 to the negative 2, or I could flip it and say it's really 2 squared, 2 to the positive 2. So that's 4. Negative 1 to the 1/2, or sorry, 1/2 to the negative 1. Told you I'm all allergied up today. Is really like 2 to the positive 1. So that's 2. Anything to the 0 power is 1. 1/2 to the first power is 1/2. And 1/2 squared is 1 squared over 2 squared, or 1/4. All right, so now I can flop these. Flip flop. Anything that was f of x becomes x. Anything that was x becomes f of x. All right, and now all I have to do is graph this new set. So that's the point 4, negative 2, 2, negative 1, 1, 0, 1/2, comma 1, and 1/4, comma 2. So it's going to look more like this time. All right, 1/2 would be exponential decay. It makes sense. So there we go. So you're going to try the very last one. You're going to graph f of x equals log base 2 of x. So again, find the inverse first, find that table of values, switch them, and graph. Pause, and when you're ready, come back. All right, so these should have been your tables of values. And then if we graph the points we have, it looks something like this. All right, and that's it for section 6.3.